I'm just going to change the essential question, though. It's going to say, how do I evaluate functions? Does it need lead? Oh, it just doesn't work. Do you need a pencil? Oh, he's giving you one. All right, how do I evaluate functions? We are getting ready to graph. Can you tell? We are getting ready to graph. So this whole unit is going to end up being a lot of graphing. All right, let's do this. All right, let's talk about function notation. Function notation looks like this. The way you say it is f of x. F of x. We could do g of x. We can have h of x, p of x. It doesn't really matter. Does that make sense? This is whatever the variable is that you're using. So this is in terms of x. I could switch it. I could have f of t, or h of t, or p of t. Normally when we use t represents what? Anyone know? Time, good. So it's terms of t, which is t is representing time. So we don't usually use t very often. We usually just use x. But when we are talking about a word problem or something like that and we want to use time, we use t as our variable, right? So this is our variable using time, and then this is just a normal variable. Has anyone seen this before? Yeah? Flip to silence. Okay. You've also seen y equals mx plus b, correct? Okay, we're not going to use y equals mx plus b. We're going to use f of x equals mx plus b. We put the x because the x is representing the variable x in the equation. Okay? So the f of x is representing the x in the equation. Good so far? So you've been dealing with functions already. We know that for every input you have how many outputs? Just one, right? We also know that for it to be a function, what cannot repeat? All your x's, which is your input, which is your domain, right? You have domain, and then what's your y values represent? Output, which is also our range, yeah? Okay?
Why are there so many different names?
Because a relation has domain and range, and a function plus you. They call it input-output, but domain and range is based on the graph also. Yeah. Oh, welcome. Yeah, I just like to. There's lots of words. And then in IM2 we use more.
Oh,
What was that? What? Just know, keep reminding you guys, IM1 is the easy class. IM2 is the harder class. So if you struggle in IM1, you're gonna really struggle in IM2. Bless you. If you get a C in IM1, yep.
Go get an F in IM2.
Pretty much.
And then you want to get in school. And then you'll be a dropout.
Oh, wow. That was like fast. Went from F to fail to drop out.
do a lot of people drop out?
No. A lot of people usually go to Alboard as their solution because then they only go to school for half a day. And they work at their own pace. But you're not taught. Like there's a teacher, but they don't, some teachers like help you and like teach a little bit, but most of it's like packet work. It's like you can go to math class, but there's like, you're working on IM1, he's working on IM2, someone else is working on something else, and you're all with just the same teacher. It's a little different. All right, so this function is f of x equals negative 5x plus 2, and I want you to evaluate when you have f of negative 3.
So just plug it in.
So what this says is when you have x, because remember this is x, right? And it's saying instead of writing an x, I'm going to plug in a negative 3. So wherever I see x, so watch, it's really easy, guys. You're going to say f of negative 3 equals wherever I see x, because that's what's being represented, I'm going to plug in a negative 3. And what's the operation between the 5 and the x? Multiplication, and we bring down that. I know, it's mind-blowing, right? And then we're going to keep solving. So we get negative 5 times negative 3,
15.
positive 15, plus 2.
So my sister was doing this.
Yeah. So we get 15 plus 2 is what? 17. Who does she have?
So that's just Jameson.
Yep, that's it. If I want to write it as an ordered pair, I think I should. We're going to write it as an ordered pair. What is your x value being represented? Negative 3. And what's your y value? 17.
You just drop that.
Yeah. This is saying when I have x as negative 3, I get 17 for my y. That's how you say, like, are thinking it. And over here, this is as an ordered pair.
Looks like equations just like that.
Yes.
She's kind of led with that.
J of x equals x minus 10, and you're going to evaluate when j is negative. You're going to evaluate j of negative 4. There we go. Destiny, was your sister using a worksheet? No? For homework? Ready? All right, we plug in j of negative 4, so we get negative 4 minus 10. So j of negative 4 is how much? Negative 14. Must you write it like this? Yes, you must. And what's your ordered pair?
Negative 4, negative 14.
Good, negative 4, comma negative 14. Yes? Okay. I'm going to trick you a little bit. Example C. It's going to say g of x is equal to 2x plus 5. want you to find x when g of x is equal to 1. So g of x equals 2x plus 5. Find x when g of x is equal to 1. I'll let you write it, and then we'll talk about it. Ready? All right, so what this says, is this saying the same thing as up here?
No.
No, why? Good, it's saying g of x is 1. So g of x is equals 2x plus 5. You're solving, find x, solve for x. So does that make sense? This does not say g of 1. It says your whole g of x is 1. So replace g of x with 1. Make sense? Okay, now do we have an equation we can solve?
Yes.
All right, so how do we solve it?
You first optimization track on positive 5.
Which is,
Negative 4.
right.
And then 2x divided by 2.
And what does x equal? Good. So how do I write that as an order pair?
Negative 2, 1. Wait.
Yeah,
Oh.
negative 2 comma 1. So remember, this is like your y value, right? So y value is 1. So when I plug this in, my y is 1. And that's how I get my answer. Does that make sense? Do we notice the difference? Okay. I'm going to do one more example. It's not going to be algebra-based. It's going to be graph-based. You ready? So we're going to draw a graph. You love math?
My favorite.
That's good. I ruin that for people in IM2, just so you know.
I won't be having you in
Actually, it's anybody's IM2 becomes ruined. It's not that IM2 it is hard, but IM2 is completely new. Like,
I understand.
everything you do in there, you have not seen.
They should change that. They change everything else.
You should make it harder.
It's pretty hard. So that's why people struggle, is because everything, they're used to just, IM1's cake. And they get to IM2 and they still don't do their homework and they think they're going to pass test, and that usually doesn't happen. Mm-hmm. I like ice cream. Yeah. Bless you. Oh, that's not a point. Ready?
No.
It's 8 over right there. That's 5-4. I mean 5-8. You need to know a point?
What's the
This one?
Yeah.
5-8. I'll read you the points to make sure you have them all. Ready? All right, so the first one over here is 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 0. So you should have negative 8, 0. Then you should have 1, 2, 3, 4, 5. Is it 5? 5, 4. Negative 5, 4. Negative 5, positive 4. Then you should have negative 2, comma 0. Negative 2, comma 0. Then you should have 0, negative 4. 0, negative 4. Good. 2, comma 0. 5, comma 8. 5, comma 8. And 8, comma 0. Good? Questions?
So it's 5, 8, and 8, 0.
Yeah. Okay, let's draw this. Ready? Mm-hmm. It's a piecewise function. We do functions like this in IM2.
How is this a function?
Hmm?
How is this a function notation? I thought it was like graphs.
It is a graph. Function
It's like
notation.
a table. Sorry. Like you do tables. You do both?
We are not going to really do tables.
Okay.
You did tables in 8th grade. We're not going to do tables. And so
Do you
we,
have to graph for homework?
no. Mm. You're just doing exactly what I've done in notes. We're not graphing yet. I think next week. What's today? Wednesday? Just kidding. I think Friday. Oh, no, not even Friday. We're just talking about characteristics. Monday. Ready? This is a piecewise function. No. It's a piecewise function. It's a piecewise function. Piecewise function.
Lizzie, I didn't know. We can ask.
It's a piecewise function. And IM2, then you do all of this to go with it. See it? This is called a step function. It is. It is. This is my notes yesterday, guys. 1, 2,
Just for yesterday?
3.
How many notebooks do we need?
Just one each semester. I'm about halfway. I'm like, that's, yeah. All right, you ready? I'm going to write down the problems. Here we go. The first problem is f of negative 2. The second problem is f of 5. The next problem is f of 0. And the last problem is find x when f of x is equal to 2.
When it just
I'll show you in a second. So let's write down the problems. And then we're going to talk about it. Romeo, this would be a parabola if it didn't keep going. The parabola is just the u. So either this u, or this u, but it's 3 put together. So 3 of them put together is a piecewise function. Because piecewise means I can put different functions all together. Makes sense? Piece of functions. Okay, ready? Okay. F of negative 2 means, what am I looking for? What's negative 2? X or Y? X. So I go to my graph, and I go to negative 2 on the X, and I get what? What's that point? Negative 2 comma 0. I'm looking for where the graph is touching. Do you understand? So if the graph wasn't touching here, it would be a different number. But because it's actually touching here, then my answer is 0. Do you understand? Because my graph is touching right here, then it's 0. So watch. We're going to keep going. Watch me do f of 5. So I'm going to go f of 5. So that means x is 5 or y is 5? X. So I'm going to go to 5 on the x. So that's to the right. There's 1, 2, 3, 4, 5. Well, there's nothing right here, but I need to find where the function is. Is it up or is it down? Up. It's up. So I'm going to find that point right there, and we know that's 5 comma 8. Does that make sense? Okay, so now go do f of 0 for me. Do f of 0.
So you need a graph or you find f of x?
I'm reading the graph to find the f of x. Because I didn't give you the actual function. You're not plugging it in on this one. You're reading the graph to see if you know where it's at. And I give you a weird function and not a line. All right, so what is f of 0? Very good. Make sense? Just right there. Okay, now this one is different. Now listen to the way it reads. Find x when f of x is 2. This one was find the x value of 0, right? So find your y. This one says when x is 5, find your y. This one said when x is negative 2, find the y. This says find x when f of x is 2. So in other words, what is representing 2? The x or the y? The y. So this is y, right? Think of this in terms of y. When you're thinking about it, think of y. So watch how this works. You ready? Watch. I'm going to use a ruler so you can see it. I'm going to go where y is 2, right? So go up my graph, go to 2. You see it? Now, do you see lots of points here?
No.
You don't?
Not all.
How many do you see?
4.
Good, there's 4. So watch. Let me grab a different color. Because we're looking for when y is 2. Does y matter if it repeats? No. The only one that can't repeat is what? X. So when I look, I see a point here. I see a point here. I see a point here. And I see a point here. Do you see them? Do we see all the points? Okay. So now what I need to do is I need to now write what my x values are. So go ahead and mark your graph first. Am I going to have 4 different answers?
Yeah.
Yeah, I am. And I need to estimate as best as possible, okay? So we're going to try to read as much as we can here. All right, so I marked all of them so it's a little easier for me to see. This first point looks like what number is x? Negative what? Negative 7. That looks really good. This one looks like it's what? Negative 3. This one, is it really over or is it kind of in the middle? Kind of in the middle. So what do we want to call that point? 2.5 is a good number. So 2.5. And then this point here, is it all the way to 8 or is it before 8? Before 8. So go ahead and estimate that value for me. What do you want to say? 7.5 or a little bit more than that. Good. Somewhere in there. Yeah? As long as you're not telling me like 7.1. or 7. Do you understand? So what it says is right now it says when f of x is 2, so when my y value is 2, I have 1, 2, 3, 4 answers. Do you understand?
You just have to write out the x.
Yep.
You don't have to graph it.
No, it's already graphed for you.
Put it in order pairs.
Only if it asks for it. So could I put it in ordered pair? Yeah, let's put it in ordered pair just to see what it looks like. So what's the first ordered pair?
-7.
Comma.
Oh, wait. No,
2. Good. So my next ordered pair.
-3,
Negative 5?
2.
2. Remember, my y is always what? Yeah, because f of x is 2. My y value is always going to be 2 on this one. So 2.5 comma 2. 7.7 comma 2. Understood? Other questions?
So there's no relation between the f -2 and the 0 thing? The top part?
These?
That? Yeah.
Yeah, these are ordered pairs also.
No, I know, but like there's not, they're not related to the x part. Like you wouldn't have to put it in order pairs.
I could. -2 comma 0.
No, I'm talking about that.
This one's?
Yeah.
This is 4 different problems.
Okay.
Okay.
Why do we need to do the ones up top if we need it for the actual answer for the one?
There's 4 different problems. 1 problem, 2 problems,
Oh.
3 problems, 4 problems. Make sense?
Yeah.
It was just broken up. So on your homework, are you going to have 1 graph? You are. Is he going to have 6 different things to do? Yeah. Something like that. I don't know how many problems it has. But it's going to ask you like to find f of 5. And you have to read the graph. Or it's going to say, what's x when f of x is 1? Okay? So that was 4 different problems. Do you understand? I could write them all as ordered pairs. Yes? Are there questions? I'm done.
Number 4, there's 4 answers.
Yes. If I would have picked a different y value, let's say I would have picked y to be 8, there would only been what? How many answers? 1. So if I said f of x was 8, then I'd look and there's only 1. Because I picked one right in the middle, I had 4 answers. I could have picked one down here and then I would only had 2 answers. Just depends on where I pick it.
Why would you have to choose that one? Oh.
Uh-huh. Make sense? Okay. Uh-huh. Because I intersected the graph that many times. All right, questions and summaries.
How many questions do you need? Just one.
No, you need more than 1. You need 1 for evaluating, at least. I would probably write something to do with the difference of these two. And I'd probably write one for reading the graph, and I'd probably do one for solving the functions. So I'd have at least 2. One based on the graph, because the graph is different than actually plugging it, right? And then I would also, so I'd probably actually have 3, because this was one kind, that was another kind, and that was a third kind. Make sense?
Is there a specific name for C? Like, is it different?
There's no name. It's that we evaluated, was it g of x or j of x, or what was it? G of x?
Yeah.
We evaluated g of x when g of x was 1. So it looks different than saying g of 1.
Okay.
Do you understand?
Yeah.
Okay.